HVAC temp rise formula to measure airflow cubic feet per minute. Airflow equals furnace output in British thermal units per hour divided by 1.08 times temperature rise in degrees Fahrenheit, and your readings must be clean of radiant heat error to avoid oversizing or unnecessary callbacks. Use a calibrated digital thermometer with a fast response probe and let the system run for at least 10 minutes to reach steady state before recording supply and return temperatures. Measure return air temperature upstream of the blower but downstream of any bypass or fresh air mixing so you are sampling true entering air. For supply temperature, place the probe in the main supply trunk at least 2 duct diameters downstream of the heat exchanger or electric heat strips, avoiding elbows and takeoffs that cause stratification. Insert the probe tip centered in the airstream, not touching metal, and seal the test hole with putty during measurement to prevent infiltration. Record furnace output from the nameplate, then adjust to actual by multiplying by measured voltage ratio and staged heat configuration, especially on multi-stage gas or modulating electric elements, so the British thermal units per hour value matches the stage you tested. Compute airflow as British thermal units per hour divided by 1.08 times temperature rise, then cross-check against blower tap charts and external static pressure to validate that the number is not an outlier. If electric strip heat is installed, de-energize all but one known element during testing. Verify amp draw on that circuit, and calculate actual British thermal units per hour as volts times amps times 3.412 to eliminate assumptions. Log ambient room temperature, return humidity, filter condition, and any bypass damper positions. These context notes explain odd rises and make repeat tests consistent. One of the biggest mistakes with airflow testing and HVAC diagnostics is placing the supply duct temperature sensor in line of sight of an electric strip heater or heat exchanger, which skews search engine optimization queries about airflow cubic feet per minute and temperature rise. Fix it by moving the probe further down the duct, at least 2 duct diameters away, and shielding it from radiant heat with a short section of aluminum foil duct shield or a right angle placement behind a turning vane. One of the common issues is measuring in a turbulent zone near an elbow, takeoff, or coil, leading to stratified temperature layers and false low or high temperature rise. The cure is to select a straight run and use a traverse with multiple insertion depths across the duct, averaging 3 to 5 points for a stable result. One of the frequent errors is using nameplate British thermal units per hour without confirming which stages or strips are active, causing wrong airflow cubic feet per minute. Verify staging via control board status, measure amperage on each strip, confirm gas input with manifold pressure and orifice sizing, and compute actual delivered British thermal units per hour before applying the formula. BigHomeProjects.com lists vetted heating and cooling pros who understand airflow measurement, temperature rise testing, radiant heat shielding, and sensor placement, so homeowners can get accurate diagnostics without guesswork. Contractors use BigHomeProjects.com to showcase verified credentials, collect real reviews, and connect with local homeowners who need trustworthy experts for airflow balancing, duct repairs, and precise HVAC performance testing.